I'm not hear you, Professor.
Oh, sorry. I was mute. Yeah. So again, one more time, very quickly. So my name is Abdul Mun'im Rezgi. I'm with Illinois State University. It's a little early here today. It's still 9:17 now. I was told to ask for the speakers to identify themselves. I know that, so the first speaker, Nadia Boutaher.
Yes, I'm here. Hello.
Okay. The second speaker, Salma El Hajami.
Yes, I'm here.
Okay. Third speaker, Sufyan El Mrabti. Or someone else.
I'm here.
Okay. And Sonia Swabi.
Yes, I'm here.
Okay, and then finally, Abdurraouf Dembri.
Yes, I'm here.
Okay, excellent. I like when everyone is present. So okay, so it's already 9:18. I guess the rules are every speaker will have 20 minutes, 15 minutes for the presentation, I guess, and 5 minutes for the questions. And for the audience, if you have any question, please go ahead and post your question publicly on the chat. That's fine. So that I can collect them and ask them to the speaker at the end. So let's get started. So can the first speaker go ahead? Nadia Boutaher.
Okay, thank you, Professor. I will share the screen.
Okay, it's 9:17 now, my time.
So you see the picture or the presentation? Okay.
Yeah.
So hello everybody. On behalf of our team, I would like to present our accepted paper for the Cloud Tech 20 conference, which we of. So my name is Boutaher Nadia. I'm a PhD candidate in the Laboratory of Computer Science, Systems Modeling and Decision Support at the Faculty of Sciences in Hassan II University of Casablanca, Morocco. Well, my research looks at the definition and the identification of machine learning algorithms and the optimization of these techniques in a big data context. So nowadays, big data technologies are used by several financial areas in order to help the customers making online transactions from anywhere and whenever they are. Hence, they play an indispensable role in the financial sector, especially within the banking institutions that use the credit card systems in the most of their services. That's why more those systems are used, more frauds are generated day by day. So during this presentation, we will talk about the following points. First of all, we're going to talk or to present the theoretical background of our paper. Then we will explain the methods of literature analysis that we have done or that we have used to write this paper. After that, we will present and discuss the results or the hypotheses that we have found. And then we will conclude the presentation and present the future perspectives of our work. And in the last point, we will present some of the references that we have used. So before getting more deeper in this presentation, it is very important to establish some definitions of the key concepts related to our paper or to present the related background. So the first concept that we have to know is the anomaly detection, which is simply a technique used to identify unusual patterns that do not conform to accepted behavior, called outliers or anomalies. Those outliers or anomalies can be broadly categorized as three types. So the first type is called the point anomalies. In this type, we can say that a single instance of data is anomalous when a particular data instance deviates from the normal patterns of the data sets, like we see in the picture. The second type is the contextual anomalies. The contextual anomalies, we have it when we have a data instance that behaving anomalously in a particular context, but not in other context. Then it is termed as, we can say, conditional anomaly or contextual anomaly. The third type is called collective anomalies, because a set of data instances collectively helps in detecting anomalies. So in our people, we have focused on the point anomalies type, and especially we have chosen to work on the credit card fraud detection use case, which is produced when fraudsters use the credit card of its owner or his credit account to make a specific operation he didn't authorize. So normally, why we have chosen this use case? Because it is the most explored type of financial fraud detection that has generated a huge amount of financial losses, more than the past. That's why several protection mechanisms are used to combat the current credit card frauds, such as the fraud prevention systems. But this type of systems are not efficient enough to reduce the impact of the frauds. Therefore, a new fraud detection system called FDS is designed in order to detect all types of frauds by differentiating the behavior of fraudsters from legitimate ones. But in the other side, we can find some many issues and challenges that can hinder the progress of an accurate credit card fraud detection system and lead to many negative effects like high in false alerts, slow detection, and low detection accuracy, such as we can have the volume challenge. Why? Because the amount of data and the number of attributes that used to define the habits of a card holder are very huge. We have also the velocity challenge, because we look in this area to achieve real-time detection by designing an online credit card fraud detection based on big data technologies. We have also the veracity challenge. In the credit card area, the behavior of credit card owners is changed over time and impacted by several reasons. And also we have the value challenge, because the credit card transactions contain much fewer fraudulent instances than legitimate ones. And then we have, that leads normally to imbalanced data. And after that, we have in the last point, the variety challenge. The data variety here refers to various forms of credit card data sources and diversity of processes developed by fraudsters. So in this part, we will present the methodology of work that we have followed in order to write this paper and the experiment design. So the first step that we have done is the data collection. So we have collected the existing research papers related to the credit card fraud detection area. After that, we have made three different comparative analyses of the current research contributions based on various criteria. So the first comparative study that we have done was the theoretical comparative study between these papers. The second one, normally the theoretical comparative study was based on the paper title, purpose, results, and limitations. The second comparative study based on big data challenges, like the criteria of volume of data, speed of data, and imbalance of data. And the last one was a comparative study of the existing machine learning techniques used in the collected articles based on various metrics of performance like accuracy, precision, fallout, and miss rates. So after we have done this analysis, we obtain various results. The first result that we have obtained from the theoretical comparative study normally like this. We have chosen just 3 references to make an example. For example, we have in the other side, we have found a problem with the random forest, which is the overfitting of trees in memory. We have found also that the supervised algorithms handle the data sets squeeze and perform better than other techniques. And we should focus on, you can hear me?
Yes, I can.
Yeah. Because I have a message of error in network. So I continue. So the work, we have found also that the work should be focusing on resampling techniques, etc., just to solve the problem of high imbalance rates and improve the squeakiness of the data sets. The second results was obtained from the big data comparative study. We observe here that we have a large size of the data sets in terms of the number of transactions and attributes that used to define the habits of a cardholder. So the need for reduced data is important because it helps to reduce the transaction processing time and the complexity in processing a transaction. So also we see in the speed of data that real-time detection is less than the batch one. So we need more to design an online credit card fraud detection system based on this criteria. And we observe also in the side of data imbalance that that the data imbalance normally is too high because the credit card transaction contain much fewer fraudulent instances than legitimate ones. In the last result, we have obtained, obtained different, we can say, numbers related to the machine learning techniques and their performance to solve this issue. So we have used to compare the accuracy that present the performance of the machine learning techniques. We have used also the precision, which is the positive predictive value that provide how the machine learning technique can be relevant in detecting more frauds. We have used also the fallout that identify the probability of false alarms. We can call it also type 1 error. We have used also the miss rate that measure the probability of missing a fraudulent activity. We can say here that the most efficient methods according to 4 performance measures that we have used are random forest, SVM, logistic regression neural network, and we can say also the logistic regression random forest is we can say efficient in terms of low fallout and miss rate. So we have identified by those comparative studies that we have done some of the key research challenges related to the credit card fraud detection area. So the majority of use cases in this comparative study are based on a specific data set from the Kaggle platform. Why? This is because fraud detection is often associated with sensitive financial data that is kept confidential for reasons of customer privacy. Card fraud detection systems work fast and extremely efficient with an online large volume of data. Also, the majority of implementing machine learning algorithms do not work in real-time processing. So the low application of the real-time processing makes the detection easier, but the difficulty remains in the fact that the credit card fraud detection model cannot be adaptable of any. Also, researchers have used several techniques to handle the squeakiness. We can say the squid class like oversampling and undersampling. So we can say that credit card fraud detection has a critical impact on the financial area. To avoid fraud losses, bank institutions try to develop new and advanced fraud detection techniques. Hence, this paper aimed to present the theoretical aspects of the credit card detection issue and provide different comparative studies of the existing machine learning techniques used to deal with credit card frauds. It is concluded here from this analysis that we have done that the most used and accurate machine learning techniques in the current literature are supervised techniques like logistic regression that always has a high accuracy and works well with linear data, SVM methods which can detect fraud at the same time of the transaction, and random forest and neural network that improve the classification rates. So as a future work, we can say that we will focus on the relevant machine learning algorithms identified in this paper, and we will analyze more data engineering techniques in order to propose our contribution that will be as a combined approach or hybrid solution that handle the imbalanced data issue in a side and make the fraud detection system more relevant to real-time problems in another side. And this solution can also provide more efficient classification metrics in terms of improving accuracy and precision and avoiding false alerts and missing frauds. So, and these are some of the references related to our paper or related to the credit card fraud detection area that we have used. So thank you for watching and thank you for your attention. And this is the time for your questions.
Thank you for your presentation. And well done. Any question from the audience? No questions? Maybe I have just one quick question. Do you think it makes sense to build a fraud detection system that doesn't give answers right away, I mean, in real time? So what's the, because from one of the slides that you showed, it looks like most of the solutions, they work like in batch, right? So they don't give you a real-time answer. So what's the purpose of a system that doesn't give a real-time answer?
Normally, this is the aim of our contribution, because this paper was just, we can say, the introduction for me to build a solution that can solve the other problems that we have in the existing literature. And as you can see in the slide, we mentioned that we have a lot of batch solutions. This is why I have mentioned that our solution or our hybrid solution should solve the option of the batch. So normally you are right. So we have to detect the fraud in the same time of the fraud. This is normally the performance of, we can say, an accurate credit card fraud detection system. And this is the issue that I have normally analyzed from this review article. And also I have observed in terms of performance that in the literature, all the systems that I have found, sure, they have a performance in accuracy and precision, but in the same time, they didn't have a performance in the missing rates, we can say this is we can say have a problem in the system. So also our contribution in the future article will be will treat normally the issue that you have mentioned, and also the issue of false alerts, or maybe the missing frauds that we didn't detected, and it is in the it is in the real time, it is normally a fraud.
Okay, there's another question on the chat. Could you please have a look at it, or do you want me to read it for you?
Yeah, of course.
Do you see it?
Okay. Yeah, does such study detect fraud from preventive perspective, or it is covered just the cases already done? What about the churn criteria prediction of
Potential frauders.
It is 2 questions in one.
Okay.
So that's such idea. That's and normally, like I said, the hybrid solution will answer your question. Why? Because normally the aim of the paper wasn't just to make a review of the existing methods, because there are normally issues in the existing methods. During the 10 years ago, we have not the real-time detection that the professor mentioned before, and also we have some limitations in the time of detection, and also we have the limitation of in terms of the imbalance data. Also, we have not data that the model can train and have we can say the right detection. So what about the churn criteria? I didn't understand this part of your question. Can you just
Maybe while waiting for the clarification,
Hi.
maybe one last question. Can you please tell me, like in practice, like since this is just the beginning of your work, how are you expecting to come up with data, real data from, for example, bank or for some financial institution? I mean, I don't think they would be willing to share sensitive things with you. How will you get the data?
Yes, we have mentioned this issue, me and the research team. Normally you are right, because this is the case in all the domains, and this is some I have made some research, and I have found that we can say template of the same data, of the same nature of data. So if I will not find we can say the real data, I can search the nature of the attributes that can define the cardholder habits. So, and there is some techniques that can make a template of data that will be the same as the real data. There is some techniques. I didn't have the details about this techniques, but we can say some place of data, but not the real data. But in the first step, I will try to have we can say sensitive data. Even this is difficult, but I will try to have even just we can say even just less volume of data, and after that I can produce more data on it. So
Yeah,
this is the idea, and that can be modified after.
yeah, thank you. Since we are almost out of time, can you just have a quick look at yeah, I think you have a clarification now there, but please, no more than 1 minute.
Okay. Churn criteria is present as SPSF modeling data, and is calculate the potential workers, for example, considered to leave can play risky profile. Okay. Normally our solution will be with the machine learning and with Python normally. And we will not use the SPSS, we can say, modeler or statistics. But
Do you want to take this offline with the person who asked the question? Maybe you can exchange.
Yes. I will answer the person. Yes,
yeah.
We will can have a detailed discussion after, because we have a lot of details to talk about it. Thank you for the question.
Okay, thank you so much.
Thank you, Professor.
I guess since we are exactly at the time of the next presentation, so is the next presenter ready? So the next presenter should be Salma Al-Hajjami?
Yes, I'm here.
Yeah, can you please go ahead? So you have 15 minutes.
Yes, thank you, sir. I will share the presentation.
We don't see it. Okay.
Hello and welcome. I'm pleased to present our paper entitled Machine Learning for Anomaly Detection, Performance Study Considering Anomaly Distribution in Imbalanced Datasets. The authors of this work are Salma Al-Hajjami from Sidi Mohammed bin Abdullah University, Jamal Malki from La Rochelle University, Mohammed Barada from Sidi Mohammed bin Abdullah University, and Bouziane Forka from Ayalin Company. This work is carried out thanks to the support of the European Union through the PPDE project of the FEDER FSE operational program for the Nouvelle-Aquitaine region, France. The project is supported by Ayalin Company with partners l'ISNSMA laboratory in Poitiers and the ILTRAI laboratory at La Rochelle University. So this is the outline that I'll go through as the presentation progresses. Firstly, I will present the problem background. Secondly, I'll briefly present the machine learning techniques for anomaly detection. Then I will present our experimental setup. Next, I'll discuss the obtained results. Lastly, a conclusion and our perspectives. The continuous dematerialization of real-world data greatly contributes to the increase in the volume of data exchanged. In this case, anomaly detection is increasingly becoming an important task of data analysis in order to detect abnormal data, which is of particular interest and may require action. Recent advances in artificial intelligence approaches, such as machine learning, are making an important breakthrough in this area. Typically, these techniques have been designed for balanced datasets or that have certain assumptions about the distribution of data. However, the real applications are rather confronted with an imbalanced data distribution where normal data are present in large quantities and abnormal cases are generally very few. This makes anomaly detection similar to looking for the needle in a haystack. In general, anomaly detection is a data analysis process that detects abnormal or aberrant data in a given dataset. So the definition of Hawkins, an anomaly is an observation which deviates so much from the other observations as to arouse suspicion that it was generated by a different mechanism. Anomaly detection is considered crucial because it indicates important but rare events and may prompt critical in them for intrusions. Fraud detection refers to detection of criminal activities occurring in commercial organizations. Anomaly detection in healthcare refers to detect anomalous patient records that indicate disease outbreaks, instrumentation errors, etc. In industrial damage detection refers to detection of different faults and failure in complex industrial systems, intrusions in electronic security systems, abnormal energy conceptions, etc. Recently, several approaches for anomaly detection have been developed using machine learning algorithms. They can be broadly classified in two general approaches, supervised and unsupervised. Supervised approach for anomaly detection are commonly based on classification methods. They require a dataset where the data are labeled normal or abnormal to build a predictive model. They are similar to raw class mining. Unsupervised approach for anomaly detection are commonly based on clustering methods, and they consider a set of unlabeled data. Also, they are based on the assumption that anomalies are very rare compared to normal data. Traditionally, mass anomaly detection systems have been designed for balanced datasets or that have certain assumptions about data distribution, such that data should have a predetermined and fixed distribution. In fact, huge applications, namely credit card fraud detection, climate monitoring, network intrusion detection, etc., are rather confronted with imbalanced data distribution. It is a difficult situation that leads to inaccurate results and making it an area of interest researchers. In this work, we develop an experimental setup for comparative analysis of two types of machine learning techniques in their application to anomaly detection systems in order to study their performance, taking into account anomaly distribution in imbalanced data sets. In this work, we applied various supervised and unsupervised machine learning methods used in the anomaly fits. More precisely, we are interested by methods having an official implementation within the open source distributed computing framework Apache Spark. So for supervised methods, we use logistic regression, decision tree, random forest, gradient boosted tree, naive Bayes, support vector machine, multi-layer perceptron, and for unsupervised methods, we use k-means, bisecting k-mean, Gaussian mixture model. This figure shows the general approach considered in this work. Both supervised and unsupervised approaches are based on the same master components: initialization, modeling, and performance. Initialization: both approaches load a dataset and prepare the contained data in order to build the machine learning models. Supervised approach takes labeled datasets while it's unlabeled for unsupervised case. The modeling process divides the loaded datasets into training and test sets. This process is carried out by training a given algorithm on the training dataset associated with their labels for supervised case, and for unsupervised algorithms, prior knowledge of labels is not essential. The model is built with the appropriate number of clusters. Performance: the predictions obtained from the test sets can be used to determine the performance of the trained model. For this work, we use the Kaggle credit card fraud detection dataset. It contains transactions made by credit card during 2 days of September 2013 by European cardholders. This table provides statistics for the dataset. This dataset is highly imbalanced. It contains 31 numerical features. Since some of the input features contain financial information, the PCI transformation of 28 digital input features named V1 to V28 were performed due to the confidentiality issues. 3 of the given features were transformed. Time feature shows the time between first transaction and every other transaction in the dataset. Amount feature is the amount value spent in a single transaction made by credit card. Class feature presents the label and takes only 2 values, value 1 in case of fraud transaction and 0 otherwise. Machine learning methods split input datasets into training and test sets. Generally, if the data are not correlated, then the training and test sets can be obtained randomly. But in our case, we know the time elapsed between transactions. Therefore, the data are time correlated. Thus, we split the datasets according to the time of occurrence. As there is no rule of thumb for how to divide a dataset into training and test sets, we consider the 2 important ratios used in machine learning: 70-30 and 80-20. This table shows that in the case of 80-20 rule, the percent of positive class of test datasets falls below 20% of the total fraud. So this can be negatively impact the performance of the method studied. In conclusion, we choose the 70-30 rule because it gives a percent of positive class close to 20%. The following figure shows the adopted architecture based on the cluster mode, where everything runs inside the cluster. Indeed, the Spark driver runs inside an application master process, which is managed by Yarn on the cluster. In this mode, the client can go away after initiating the application. In client mode, the driver runs in the client process and the application master is only used for requesting resources from Yarn. Our experimental platforms contain 1 master node and 3 worker nodes configured as follows. Evaluation metrics play an important role to assess and guide learning algorithms. In our case, the major challenge is to tackle the imbalance problem, since legitimate transactions are much more numerous than fraudulent transactions, less than 1% of total transactions. This problem often leads to extremely high accuracy, where a model can reach up to 99% of the prediction accuracy, ignoring the 1% of minority class cases. In other words, the accuracy does not reflect reality in this data imbalance case, especially for the positive class. For this reason, we will also use the IUC metric to measure if a model is able to distinguish between the two classes, in particular in the case of the imbalanced set study. In order to better situate the results, we start by reporting on accuracy of supervised methods. In the following figure, we see that accuracy of supervised algorithms is more than 99%. When dealing with such severe imbalance data, we need to be careful when measuring model performance, because there are only a handful of fraudulent instances. A model that predicts that each example belongs to the negative class will already achieve more than 99% accuracy. Therefore, this doesn't help us to find fraudulent cases. And now for IUC metric, in the following figure, we can see that the two algorithms, support vector machines and naive have the lowest performance, which means that these models have no class separation capacity. Logistic regression, decision tree, and gradient boosted tree models obtain a moderately good result, but not the best, followed by random forest. Finally, we can see, or we can point out that multi-layer perception model obtains the best results and gives the best class separation capacity. The following figure shows the results obtained by unsupervised models. From the point of view of accuracy measure, Bisactin Camins obtains the worst performance, while Camins obtains the best accuracy. Generally, the IUC score is low for unsupervised algorithms. Finally, we can say that in this general case, the supervised models gives more interesting results than the unsupervised models. In the rest of our experiment, we studied the impact of the distribution of minority class data on the performance of learning algorithms. So for that, we will be interested only in the data features which are able to make aspiration between the two classes. Visualization techniques can be helpful in this process. Formally, we select a subset of features from the feature sets and eliminate redundant ones that do not contribute to performance. Thus, a feature is important when its data distributions of the two classes are divergent. Therefore, this feature can potentially separate the two classes and improve prediction performance. Let us take the example illustrated in this figure, showing the data distributions of the two classes for time feature. We can see that the distribution of normal transactions corresponds to the distribution of fraud transactions. This means that the time feature cannot effectively contribute to performance. Same conclusions for the feature amount and bit 13. For V12 feature, we can see a significant divergence of the two distributions. It's a feature with a strong predictive power, so we can keep it during the model constructions. As a result, 11 relevant features were selected for our experiment. Different experiments were conducted to study the effect of imbalance rates in the performance of the supervised and unsupervised models. The following figure shows the different parameters considered for these experiments. Firstly, we studied the supervised and unsupervised methods separately. The experiments take into account only the relevant features. For the positive class, we studied 4 different divisions for the train and test datasets. From the following figures, we can observe that as imbalance rate increases in training sets, accuracy and IUC decrease considerably. And the usual distribution of our data case, 80-20% with the relevant features, is the best to use for the training the supervised models. These figures show experiment results obtained by the unsupervised models. We can observe that the distribution of our case 60-40 rule with the relevant features is the best to use for training the unsupervised models. As a conclusion, in this work, we present a comparative experimental study between different techniques based on machine learning approaches for anomaly detection. We show the impact of data imbalance on the performance of these approaches. Thus, from the obtained results, we know the existence of a set of parameters suitable for supervised and others for unsupervised models. As perspectivists, we plan to address several problems, in particular the generalizations of these conditions according to data volume, their nature, etc., and consider other approaches arising from recent developments in learning algorithms. A comparative study between our experiences and other work is also underway. So thank you for your attention, and I'm here for any question.
Thank you for your presentation. So I'll first ask the audience, does anyone have a question for the speaker? If you have a question, you can either, say it or you can write it on the chat. Maybe while waiting, a quick question. So have you thought of methods to actually make the data balanced?
Actually, there are various approaches that have been proposed to deal with imbalanced data sets. But in this work, we are just interested by machine learning techniques that have an unofficial implementation within the open source framework Apache Spark, in order to study their performance when they are faced with imbalanced data.
So did you actually do a real implementation? Because I saw that you mentioned Spark at some point in time.
I didn't understand your question.
Did you do an implementation on this?
Yes.
So in terms of response time, because this is kind of related to the presentation before you, do you have an idea like about the time that you are getting in terms of detection? Like in the order of seconds or minutes or?
The time of prediction and training?
No, the time of detection of anomalies.
I didn't do this comparison.
And the time of training?
Yes.
Yeah, but you measured the time of training, right? Or no?
No.
Okay. Any question from the audience?
I have a question.
Go ahead.
Have you thought about combining between supervised learning and unsupervised learning in resolving the data detection anomaly?
No, we are not considering the hybrid approaches. We just study the performance of the two types of machine learning techniques.
Okay.
In order to understand their weakness when they are faced with imbalanced data.
Okay.
Any other question before we move to the next presentation? So if not, then thank you to the speaker. If the third speaker is ready. I was told that paper 73 is going to be skipped. So the next speaker now is Sonia Swabi.
Yes.
Yeah, the third speaker is not available, it looks like. So you will be the third. The floor is yours. And I guess since we don't have a third talk, maybe you may have like 20 minutes, I guess.
Okay. You can see the presentation.
Yeah, you have 20 minutes for the presentation and 5-7 minutes at the end for questions.
Okay. Dear scientific committee, dear colleagues, I'm Sonia Swabi from the Networking, Modeling, and E-Learning Lab of Mohammadi School of Engineers in Rabat. And I'm glad to be here with you today to talk to you about my paper entitled A Recommendation Approach Based on Correlation and Co-occurrence within Social Learning Network. The outline of the presentation highlights the introduction and research problems by discussing e-learning recommendation systems and focusing on the research question, then highlighting the proposed approach by defining our recommendation approach and its benefits, finally summing up with a conclusion and future directions. Online learning occupies a crucial role in promoting easy access to the various learning materials. E-learning is learning utilizing electronic technologies and devices to access educational curriculum outside of a traditional classroom. Recent developments in the field of intelligent learning environments have led to a renewed interest to social learning due to its collaborative and interactive properties. Recommendation systems have been widely adapted in recent decades. It's a system intended to provide adequate items to users in order to optimize research time and arouse their interests. Researchers are thus starting to pursue its various applications, notably social learning. There are several types of recommendation systems. Content-based recommender systems. It's one of the common methods involved in recommendation systems. Content-based filtering methods are based on a description of the item and a profile of the user's preferences. Collaborative filtering recommender systems. One approach to the design of recommender systems that has wide use is collaborative filtering. Collaborative filtering is based on the assumption that people who agreed in the past will agree in the future, and that they will like similar kinds of items as they liked in the past. Hybrid approach. Most recommender systems now use a hybrid approach, combining collaborative filtering and content-based filtering and other approaches. There is no reason why several different techniques of the same type could not be hybridized. Hybrid approaches can be implemented in several ways by making content-based and collaborative-based predictions and then combining them. The only problem to be reported is actually that most studies on recommendation systems within social learning consider learners' ratings in their recommendation systems, which is acknowledged as unreliable indicators for generating recommendations. On the other hand, researchers focus on the explicit data of learners rather than implicit data based on their interactivity within the learning environment. We carried out an overall analysis. We carried out an overall analysis of the recommendation systems already in place in terms of social learning, and found that most studies do not address the activities carried out by learners to generate more interesting recommendations. So how can we address this issue in order to propose a more interesting recommendation system? In the current work, we propose a hybrid recommendation system combining correlation and concurrence between activities carried out by learners in the learning environment. Generally, learners are more interactive and collaborative within a social learning network. To generate more appropriate recommendations, it's important to rely on the implicit data instead of explicit data and item ratings. The major components of our model are the activities performed by learners, including primary and secondary activities, data preprocessing, learning objects or learning resources, the recommendation engine, and the group recommendations generated. In this section, we explain how the recommendation model works. First, activities carried out by learners. We identify the activities carried out by learners, taking into account in our recommendation system. These activities can include the number of likes, the number of comments, the number of posts according to the social network. The choice depends on the priority assigned to each type of activity. The activities are classified into two types: The primary activity, this is the activity directly associated with the recommendations and represents the most frequent activity by learners within the social network. Secondary activities, these are the less frequent activities coming in the second position. By comparing the history of the primary action with other actions, you can find the actions leading to the one you want to recommend. Everything we know about the learner can be used to improve the recommendations. Second, data preprocessing. Data about learner activities is prepared and pre-processed in the right format for recommendation engine as the data preprocessing component level. Finally, the recommendation engine. After preparing and preprocessing the data, the recommendation engine calculates the observed correlation and co-occurrence between the different activities performed by learners. Using the history of the activities and how often they have been performed, we will compute the correlation between the primary activity and secondary activities, as well as the co-occurrence between the primary activity and secondary activities for each learning object. Then we estimate the correlation score on the one hand and the co-occurrence score on the other hand for each learning object to obtain eventually the total score combining the correlation and the co-occurrence. Let's define the correlation and the co-occurrence. The correlation between two variables or two activities in our context is a notion of connection that contradicts independence. The more dependent two variables are, the higher the correlation coefficient between. The co-occurrence, for the co-occurrence, this notion of connection makes it possible to ascertain how many times two activities have appeared together. So to calculate the total recommendation score, we combine the correlation score and the co-occurrence score as to obtain the presumed results. So let's consider the A1 to AM history activity, the history activities performed by learners, and from I1 to IN, learning objects to recommend. So the correlation score matrix will be the history matrix multiplied by the vector from 1 to correlation between the first activity and the other secondary activities, which gives the correlation score for each learning object. The co-occurrence matrix, it's given by the binary history matrix multiplied by the vector from 1 to the co-occurrence between the first activity and the other secondary activities, which gives the total score matrix, which is the correlation score matrix plus the co-occurrence score matrix. So to generate top N recommendations for target learners based on the correlation, the co-occurrence between the activities performed by learners, we adopt the following algorithm. So the input should be set of activities, the primary activity, the secondary activities, the set of learning objects, and the history matrix. And the output will be the predicted scores and the top N recommendations. The method will be for each learning object, we will compute the correlation score and the co-occurrence score. And finally, we will compute the recommendation scores and generate the top N recommendations for learners based on the recommendation scores obtained. So our recommendation system leads to a multitude of advantages. Integrating all learner activity, we can integrate all learner activities into the recommendation system. We combine the correlation and the co-occurrence together in a single hybrid system, and we consider a learner's implicit data instead of considering explicit data such as ratings, which does not present a reliable indicator for recommendation systems. So this paper, as a conclusion, this paper focuses on a primary aspect, namely the recommendations in terms of social learning. Learning-oriented social networks contain a very particular feature of learners who are generally overly dynamic. We therefore propose a recommendation-based approach, emphasizing this aspect and encompassing all learners' activities. This approach tends to combine the two correlation and co-occurrence parameters by dealing with implicit data. With other terms, we are targeting implicit actions to implement our recommendation system while learners are aware of it. As prospects for the future, we intend to test this approach on a real learner database to provide meaningful results, compare our approach with other explicit approaches in terms of recommendations, and cluster learners into communities before adopting the proposed recommendation approach. And thank you for your attention.
Thank you. Well done. Any question? Any question from the audience? So if you have any question, please post it on the chat. So while waiting, can you please go back to slide number 6?
Yes. Yes.
So at some point in time, not this one, number 6, you said, yeah, so that certain recommendations are deemed to be unreliable. Why is that?
Because they are based on ratings given by learners. For example, when we recommend a resource, a learning resource to a certain learner, they can rate them from like 1 to 5, and they can like give a rate of 5, and in reality they didn't like the resource, the content. So that's why we think that giving ratings in recommendation systems in general can be considered as sometimes as a reliable indicator to recommend system, to recommender systems. Yes.
Yeah, but I mean, it might be the case in certain cases, but for example, if you take Amazon, I mean, someone would not rate a book as good if the book is bad. If that person finds the book not readable, then why would someone rate a book as good if he or she doesn't like it?
Because our context is different. It's about learning. So we think that learners can rate something without thinking it's good for a lot of reasons. I don't know. Maybe he's afraid to say that the content was not good or something like that.
Okay. So essentially because of external factors.
Yes.
And any question from the audience? I don't want to monopolize the floor here. Any other question? If not, then I guess I can go on with another last question maybe. I'm still not clear. Why are you distinguishing between primary and secondary activities?
Because the primary activity is the first activity concerned by recommendations. For example, when in the literature, when they want to recommend some items based on ratings in the literature, they consider, for example, giving ratings as the only activity to consider. But in our proposition, we intend to consider a lot of activities or a lot of actions done by learners to give more value to our recommendation system. We consider like number of likes and number of comments, number of posts, all these things together to enhance the performance of our recommendation system.
Interesting. Yeah, I see. Any other question? So if not, I guess we should thank the presenter. It was a nice presentation, and I guess we are now getting to the last presentation of this session, and that's Mr. Dembry. Is the presenter here?
I'm here.
Yeah. First of all, the presenter of paper 73, because at the beginning I remember I had 5 presenters, and I'm getting a notification that paper 73 is not going to be presented. If you change your mind, let me know. If not, then Mr. Dembry, the floor is yours.
I'm ready.
Yeah. Okay. Go ahead. Are you able to share your screen?
Yes.
Okay. Sorry. So you have 20 minutes for your presentation, and maybe 5 to 10 minutes at the end for the questions. It looks like you are muted. We can't hear you. We can't hear you. We can't hear you.
Okay.
I can't hear you, at least. Yeah, there is no audio.
Hello everybody, I am Abdurraouf Dombri, PhD student in MISC Laboratory, Abdelhamid Mehri Constantine to University of Algeria. In this presentation we talk about graph-based models for negative electronic word of mouth influence in social media. In this presentation we start by introduction, next talking about our contribution and the aims of this study. In the method, we explain and clarify the contribution in 5 steps as follow: collecting data, classifying the electronic word of mouth, grouping negative electronic word of mouth, generating the influence graph of negative electronic word of mouth, analyzing the influence graph. Finally, we conclude with the area of the interest and future work. In recent years, there has been an increasing interest in the social media marketing. This last is an innovative tool that allows companies to create ads, display products or services, connect with the audience, increase sales, and drive the website's traffic. People give their opinions as user-generated content by providing the EWOMs about services, products, or brands. For this purpose, companies target potential buyers by analyzing their content and attract their attention. Social ties are the source of trust relations, such as being followers, friends, or even belonging to the same region. Customers exchange their feedback about services using EWOM, and many of them check the existing reviews before deciding if they want to purchase a new product. This feedback has a powerful influence in company customer's experience in social media. The electronic word of mouth is persuasive or funny enough. In our contribution, we propose a method for determining the negative EWAM's influence on consumer opinions. This method helps companies to prevent the spread of negative opinion, detecting the anomalies, make right decisions, like improving the products or pulled it from the market, fixing bugs, detecting the most influencing EWAM. The proposed method consists of 5 steps. The first one is data collection. Step 2, EWAM classification. Step 3, EWAM clustering. Step 4, influence graph generation. And the final step is graph analysis. We start by step 1, data collection. In this step, we use already existing data that we got from the Kaggle website. The table represents the tweet of United Airlines service. The first column represents EWAM ID, the name of the person who provided an EWAM, time of tweet created, used for represent causal order between EWAM, tweet location that we use it as a social size. This allows us to know the people who belong into the same region. Tweet that represents the electronic word of mouth. Finally, the label that represents the polarity of tweet. This last can be positive, negative, or neutral. Next step is EWAM classification. We use a random forest as a machine learning algorithm. This algorithm can be used for regression, classification, and supervised learning. The output is EWAM polarity, and it's represented in 3 classes as follows: positive, negative, and neutral. The results we got are 16% positive, 21% neutral, and 62% negative. This means that the negative opinions are 4 times greater than positive opinions. Step 3, EWAM clustering. In this step, we use cosinus similarity for grouping the similar topics where each EWAM discussed one topic. The similarity between 2 sentences S1 and S2 is defined as the cosinus of the angle theta between the corresponding vector u and v. The cosinus similarity is calculated by the following formula. The cosinus of the angle between 2 vectors with the same orientation have the cosinus similarity of 1, and the 2 vectors oriented at 90 degrees related to each other have a similarity of 0, and the 2 vectors diametrically opposite have a similarity of -1. For computing corresponding vector u and v, we use pre-trained model called sense2vec. The first part is similar to second part. This means the sentence 1 is similar to sentence 2. For example, if we have topic 5 and topic 1 is similar, we put them in the same group. And if we have topic 2 is similar to topic 1 and topic 5, we put them in the same group. If we have topic 4 and topic 3 is similar, we put them in the same group. We use the agglomerative strategy of hierarchical clustering to organize EWAM based on cosinus similarity. The dendrogram illustrates the arrangement of the cluster predicted by the corresponding similarity. This allows a distinction between the main topic and the subtopic. This image represents hierarchical clustering of all topics based on similarity. If we take loss luggage and damaged luggage, the similarity between them is zero. Problems, the hierarchical clustering regroup them in the same subtree. Next step is generating the influence graph of negative ions. Firstly, we represent each ion by node. This link represents the social size, and this arcs represent the similar ion. The idea is check for each two similar ion. If the social size is appeared, this means the influence. If we take ion 8 and 7 is influenced by ion 6. This image represents the influence graph of negative ion related to our case study. The precedence between ion represented by arc orientation. This graph is a combination of precedence, similarity, and social size. The graph analysis phase depends on the structure of the graph generated in the last step. The out degree centrality refers the highest number of the outgoing arcs from the one node. This node represents the highest degree. This means the person who is the most influencing one. This graph helps manager to detect the anomalies like spread of bad information. It was at this part we inject more influence person to clarify our method. The closeness centrality refers the average distance from a node to another. This means the average influence depth, and we use this metric to determine the person who convey negative ion. This figure represents between-us centrality. The between-us centrality refers the number of the appearing in the shortest path between the nodes. This node appeared in the shortest path. This is encouraging the spread of ions, and if we could influence them, we will affect the spread of opinions, and it permits managers to target a central participant to spread awareness and make a change quickly. We conclude with the area of the interest and future work. Our work could be the basis to analyze the negative influence and control both individual and markets. Explore positive EOM to help companies in detecting emerging markets to make free advertising based in the viral marketing. Detecting the intentions of customers to diffuse negative opinions about competitive products using botnet. Measure the graph density and detect the patterns to track the evolution of the negative and positive EOM. Using strong social ties for hinder the spread of negative EOM. Thank you. Any question?
Thank you so much. Nice presentation. Any question from the audience? Any question? While waiting, can you please go to slide 16 if you have it?
Yes.
I mean, when you showed it, no, okay, can you please show it like in full screen? Because
Okay.
Can you, no, I wanted to talk about the graph itself. So at some point in time, you showed those social links between the social ties, you called them, between the vertices, right? Not this figure, maybe it's another figure. Where the figure that show, yeah, this one, yeah, it's still 16, I guess. So what do you mean by social ties between the EWOMs? The EWOMs are just, comments, right?
Yes, electronic word of mouth.
Yeah, so what do you mean by social ties between them? I mean, they are not people, right?
Is the E1 is represent the E1 represent the comments of the people, of the person who provide an E1. The person can be provide one or more than one E1, one E1.
Okay, and then when do you add an edge between two EWAMs? When the two people are linked socially?
If we have the hashtag or we have the identifier between EWAM, like identify a person in comment. In this data set, we use the social ties, the person who belong to the same region.
Okay, so that's fine. I have another like kind of a question that's kind of general. So your purpose, if I'm not mistaken, is to identify those influencers and to kind of target them, right? But if you go back, for example, to the that table that you showed at the beginning, those people who gave comments about United Airlines.
Yes.
So, they may live in the same location, I mean, in the same area, but it doesn't mean that they can influence each other, right? So even if they read their comments, I mean, each other's comments, I may be in Virginia and I can...
Yes, we combine between the similarity of comments and the person who belonging to the same region, and we introduce the influence.
So are you saying that people tend to kind of be influenced by people who are kind of co-located, who live close by?
Some studies indicate this.
Yeah, because sometimes, I mean, you may be in California and, you may be kind of following, or you may be influenced by someone in New York, or I don't know, Florida. So I don't know. I'm not really convinced that it's easy. First of all, is it possible to kind of identify the influencers in a network like this? And even if you can assume that someone is very influential, I mean, how can you target that person? So let's say if you are United Airlines, and if you think that you can identify 10 people who are spreading, negative comments about you, so what can you do?
I'm not understanding.
So let's say you are United Airlines and you identified Mr. X as a person who is spreading negative comments about the company. So what's the next task? The next action is what? To contact that person?
This related to the service manager that can be prevent the spread of negative opinion by giving them
Warnings?
Wait, yes.
Yeah, but I mean, people are free. I mean, they can still, they can be, they can still dislike your company.
If we got the example of the products, we can improve the products or pull it from the market.
Okay. Yeah, I see your point. Yeah, interesting. Yeah, it's an interesting study. How far are you in this? So is this like the beginning of a long project, or is this just this study?
I'm not understanding. Please repeat.
No, I was asking you, like, is this like a PhD work or a master's work or?
PhD works.
Okay, interesting. Any other question? Hearing none. If the audience has no questions, then I guess I will close the session, and I wish you good night, I guess, at your time. So here it's still morning today. Now, I mean, it's 10 o'clock now. Yeah, so I guess the organizers can take it over and disconnect, I guess, at this point. Thank you so much. Thank you all for joining this
Thank
session,
you.
and have a good night.
Thank you.
Bye.